So we're going to pick up where we left off yesterday. I've copied and pasted the steps, the 4 little steps that we did, and we're going to do 2 new problems together. If you're watching this video first, I appreciate it, but I'd like you to stop right now, open up the assignment for today, and copy down the problems. The first 2 are going to be the 2 that I do here in this video, and then the other 2 are going to be your assignment. So you can kind of do these hand in hand together. So get out a sheet of paper, write down this problem. We're going to work it out. The next one, we're going to work it out, and then the other 2 are going to be your homework. So the first step doesn't change on any of these. The first thing you need to do is find your slope. So you're going to start by calculating your m, 5 minus 1, y2 minus y1, over negative 5 minus 5 for the denominator. So your slope winds up being 4 over negative 10. Now, I'm asking you guys to reduce this, okay? Both of those are divisible by 2, so I'm going to divide both by 2. That is negative 2 fifths. So I divide both by 2. I'm in the habit of putting my negative up in the numerator, and that'll come into play here in a minute when we plug in our x and y values, because if you're trying to do these on a calculator and you punch in a negative in the denominator, calculator is going to throw you an error. So all I did was I slid that negative that was on the 10. When I reduced my fraction, I put it up on the 2 in the numerator. All right, so that was step 1, find our slope. Step 2, I'm going to pick a point. I'm going to use 5, 1 because there's no negative. But again, it doesn't matter. The other one will work. You're going to have some different numbers along the way. So when I plug this in, y equals, oh, I'm sorry, let me back up a step. I don't want to leave anybody behind here. I'm going to go to my kind of generic slope-intercept equation, and I'm going to plug in everything that I have so far. I have a y value of 1. I have a slope of negative 2 fifths. I have an x value of 5, and I'm trying to solve for the b. Okay? If I did my job right in coming up with these problems, when you multiply your m and your x, you will get a whole number every single time. So don't let that negative 2 fifths worry you too much, because when I multiply negative 2 fifths times 5, that's just going to result in the negative 2. Okay, so now my goal is to get the b by itself. So that negative 2 needs to be added on to get rid of it. Since it was negative, that's going to leave my b to have a value of 3. All right, that was step 3 right there, is to get that b out of it. Now I'm going to put it all together and actually write the equation. For my last step here, step 4, y equals negative 2 fifths x plus 3. And there's your equation in slope-intercept form. We are ultimately, tomorrow, I'm going to have you guys come up with the equation and graph the result. All right, next one, last one we're doing together. The other 2 are your homework. So I need to come up with the slope again. So my m is negative 3 minus negative 5 over 0 minus negative 4. That's going to leave me 2 over 4, so 1/2. That's a nice fraction. Go back to your y equals mx plus b and plug in. It doesn't matter which point you pick. Again, I'm partial to zeros because when you multiply, they're gonna go away. So I'm going to use 0, negative 3, so y is negative 3. My m is 1/2, my x is 0, solving for b. 1/2 times 0, 0. So b is negative 3 on that one. Okay, I've got all of my pieces now. I've got my xy pair from up here. I've got my slope that I just found. I've got my slope and my y-intercept. So last but not least, put it all together. Y equals 1/2 x minus 3. Okay, you've got 2 more problems I'd like you to do on your own for homework, but I want to see all of this together when you take your picture to turn it in, okay?